Okay. So what is the previous topic? Last topic. Here. So scalar potential field. So what is the definition of? So before going to the next topic, so just I will give the brief idea of the scalar potential field. So what is the scalar potential field? So if suppose the given vector function, so vector point function f, there exists a scalar point function pi such that f is equal to, we will write the del pi or f is equal to gradient pi, then this pi is called as scalar potential field of the given vector field f. Okay, now here the properties of the scalar potential field. Here if pi is the scalar potential field, then definitely f is an irrotational vector. So this is not implies, it is the by implies. So already we have seen. So find the gradient of f is the gradient of pi, just to find the curl of this f. The curl of f is 0. So if pi is the scalar potential field of f, definitely f must be the irrotation vector. That is the first property. Now what is the second property? The second property is if f is an irrotation vector, there exists a function. That function is the scalar potential field such that f must be is equal to del pi or gradient of pi. Del pi or gradient of pi. So del pi or gradient of pi. So this is the second property. Now come to the third property. What is the third property? So here I am taking f is a vector point function, f is equal to f1i plus f2j plus f3k, and pi is scalar potential field of f, and definitely, so scalar potential field means what about that means? So here f is equal, we will write the gradient of pi. So gradient of pi. Then definitely f1 dx plus f2 dy plus f3 dy must be 0. So this differential equation must be the exact differential equation. So this is the our third property. And moreover, del pi we will write. So del pi, that means d pi, we will write the d pi is equal to f1 dx plus f2 dy plus f3 dz. So this is the our second property. So third property. Next one, come to the fourth property. So the fourth property is the necessary and sufficient condition for the exact differential equation. So in the two variables we know that dou m by dou y. Okay, so I will write here the statement. So in the two variable, what is the necessary and sufficient condition for the exact differential equation? M dx plus n dy is equal to 0 is an exact differential equation. Exact differential equation. What is the necessary and sufficient condition here? Then definitely dou m by dou y is equal to dou n by dou x. And here also same. Suppose if f1 dx plus f2 dy plus f3 dz is equal to 0, assume it is an exact differential equation. So exact differential equation. Now what we are getting here? So easy. So this one is exact differential equation. That means f. So already it is clearly given f is equal to gradient of pi. That means f1 is equal to dou pi by dou x, and f2 is equal to dou pi by dou y, and f3 is equal to dou pi by dou z. After rearranging, here we will get the dou f1 by dou y is equal to dou f2 by dou x. Similarly, dou f2 by dou z is equal to dou f3 by dou y, and dou f1 is by dou z is equal to dou f3 by dou x. So that is the necessary and sufficient condition for this exact differential equation. So here the necessary and sufficient condition is dou f1 by dou y is equal to dou f2 by dou x, first one, and dou f1 dou z is equal to dou f3 by dou x, and the third one is dou f2 by dou y, so dou z is equal to dou f3 by dou y. So this is the necessary and sufficient condition for the exact differential equation. And moreover, one more point here I am writing. So f1 dx plus f3 dy plus f3 dz is equal to 0. And moreover, here the f is equal to gradient of pi, we know that. And if it is exact differential equation, definitely here curl of this vector f must be 0. Curl of vector, curl f must be 0, where f is equal to f1 I plus f2 j plus f3 k. Okay, so this is the necessary and sufficient condition for the this correspond differential equation. Okay, so either you can calculate like this, or you can find the curl f 0. So curl f 0, if the curl f 0, definitely will get these three equations. Similarly, observe here from the first one. So mdx plus ndy is equal to 0. So already we know that here the, so this one is the exact differential equation. So here also you can write the statement like this, curl f is equal to 0. What about here f? F is equal, here I am writing mi plus nj, mi plus nj. So mi plus nj, that means I, j, k, first row, second row is dou by dou x, dou by dou y, dou by dou z, and third row is m, n and 0. Okay, assume 0. So 0, then I into, it is 0 and it is without, here mn both are functions of x only, so 0 minus j 0, and here m is only function of xy, so this is also 0, plus k into, and k into plus k into dou n by dou x minus dou m by dou y is equal to 0. So already it is 0 means dou n by dou x minus dou m by dou y must be 0. That means here dou n by dou x is equal to dou m by dou y. So simply just find the curl f. If the curl f 0, definitely the corresponding differential equation must be exact differential equation, whether the differential equation in 2 variables or 3 variables. Okay, so no need to remember this all, directly just to find the curl f. Curl f 0, definitely the corresponding differential equation must be exact differential equation, whether in terms of 2 variables or in terms of 3 variables. Okay, so this is the idea of the this one. This is the fourth property. Now I think we have seen in the previous class few problems. So the first one show that f is equal to 2xy plus z cube I plus x square j plus 3z square x into k is irrotation vector. So irrotation vector means we have to prove that curl f must be 0. So I think we have proved. So here the curl of this f is, so it is 0. So the given vector is the irrotation vector. So one more point here, if it is irrotation vector, definitely there is a scalar potential field of this f. Okay, so the question here, sub question is, and also find its scalar potential field. So scalar potential field, the calculation of the scalar potential field. So assume here the pi is the scalar potential field of this f, definitely. So this f is equal, we will write the gradient of pi, and gradient of pi, and just d pi. So actually we want to calculate the pi. Now d pi is equal to dou pi by dou x into dx plus dou pi by dou y dy plus dou pi by dou z dz. Now so already the given vector f is irrotation vector. Just substitute here. So here f is equal to gradient of pi, f is equal to gradient of pi, already it is given the f, and compare. So gradient of pi is I into dou pi by dou x, and j into dou pi by dou y plus k into dou pi by dou z. Now after comparison, dou pi by dou x is equal to this first one, and dou pi by dou y is equal to second one, and dou pi by dou y is equal to third one. So it is the our first result. This is the f1 and f2, f3, and substitute here. Okay, and it is the differential equation. So anyway, this is the exact differential equation. Definitely we will write the derivative of some function of xy. So this is the function of xy is x square y plus x z cube is the result. That means our pi is equal to x square y plus x z cube plus c is the solution. This solution is scalar potential field. Okay, and you can easily verify. So how can you verify? So already we know that f is equal gradient of pi. Already we have the pi and f. Just to substitute the pi in this one. The verification of this one. So pi is equal to x square y plus x z cube plus c, and just to calculate the gradient of pi. So gradient of pi is, we will get the f. Now f is equal here I into 2xy plus z cube plus j into x square plus k into 3z square x is the result. So like that you can easily verify. Okay, and moreover here directly in place of here dx dou pi by dou x, dx dou pi by dou y dy plus dou pi by dou z dz, directly dou pi by dou x, directly you write the f1. So assume this is the f1 and this is the f2 and f3, substitute here. Okay, so that property we will use in the next problem. Okay, so I think the second problem is to show that this is an irrotational vector. So irrotational vector means just you have to find the curl f and you have to prove that curl f 0. So for this problem curl f 0, so this given vector is irrotational vector, and the in the sub question is and also find its scalar potential field. So scalar potential field directly. So here I am assuming pi is the scalar potential field of f. That means f is equal, here I am assuming f1i plus f2j plus f3k, and the scalar potential field of f means f is equal to gradient of pi. Definitely here this d pi is equal to f1 dx plus f2 dy plus f3 dz. Already we proved in the third property. In the third property already we have seen. So d pi is equal to f1 dx plus f2 dy plus f3 dz. Okay, directly we will use that property directly. Okay, now f1 is equal to xy square plus y cube, and f2 is equal to x square y plus 3xy square, and f3 is 0. So it is now differential equation. So this differential equation must be exact differential equation according to the basic rules or inspection method, just to find the solution of this differential equation. Okay, so here the solution of the differential equation is xy square by 2 plus xy cube plus constant. So this is the solution, and this is the scalar potential of f, and the verification just to find the gradient of this pi. So definitely that the result is equal to the given vector f. Okay, so the given vector f is, what is the given vector f? I into xy square plus y cube, j into xy plus 3xy square plus 0. Okay, so this is the our second problem. Now third problem say, so here the third problem is little bit indirect problem. So find the component lambda of the vector f is the irrotational vector field, where f is equal, this one is the vector point function, but in the vector point function there is a unknown. So lambda is unknown. So the first question is, first of all find this component. That means first of all we have to assume the curl of the vector is 0. Just from that just find the lambda value. So in this one the lambda value is, we are getting 4, and the next question is here in the it is sub question, and also find its scalar potential field f. Okay, that is the second sub question. So here the lambda is equal 4. Lambda is equal 4 means the vector is, the given vector f is 4xy minus z cube I plus 2x square j plus 3x z square k is the given vector. So from this given vector we have to find the scalar potential field of f. So scalar potential field of f. So here f I am assuming f1 I plus f2j plus f3k. So this is the f1 and this is the f2, this is the f3, and scalar potential field means f is equal to gradient of pi. And according to the previous property, property number 3, so d pi is equal to f1 dx plus f2 dy plus f3 dz, and substitute f1 f2 f3 and just to solve this differential equation. After solving this differential equation we will get here the solution is xy is 2x square y minus x z cube plus constant. Verification, it is the pi, just find the gradient of pi. Definitely that result must be is equal to our given vector. Okay, so this is the third problem in the previous class, and I think I have given 3 homework problems. The first homework problem is just show that the given vector is the rotational vector and also find its scalar potential field. Okay, ఎంతమంది సాల్వ్ చేశారండి ఫస్ట్ క్వశ్చన్? The result is x cube plus y cube plus z cube minus 3xyz. ఎంతమందికి వచ్చిందండి? సిఆర్స్
వచ్చింది సార్ ఆన్సర్.
Okay, now come to the second question. What is the second result? First question okay, second question result ఏంటండి చెప్పానా? ఓకే, second result వచ్చిందా? కొంచెం మెల్లిగా చెప్పండి. ఫస్ట్ హలో, రిజల్ట్ x square
plus
2y square
minus 3z
square good plus xyz, very good. So this is the scalar potential field, very good. Next one, come to the next.
pi is equals to
y square sin x
plus
x
z cube
minus 4 is equal to constant. Okay, now from the second problem, so now I will write the general statement. Second problem, suppose f is equal to, I am writing is the function of x plus yz I plus function of y plus zx into j plus function of z plus xy is definitely, we know that according to the previous problem it is the irrotational vector, but the question is what is the scalar potential. ఎవరైనా చెప్తారా రిజల్ట్స్? వాట్ ఈస్ ద ఎక్స్పెక్టెడ్ రిజల్ట్? just observe the second question result. X square and here the 2y square and minus 3z square. So integration of, here we will get the integration of pi dx plus integration of pi 2 dy plus integration of pi 3 dz plus xyz is equal to constant is the our scalar potential field. Am I correct? You get my point? Okay, Nandi.
Okay, sir.
Now here I am giving a question. Now give me the result very quickly. So f is equal here sin x yz I plus e power y zx j plus k into 3z square plus xy k. We know that it is the must be irrotational vector field, irrotation vector. Then what is the our pi? చెప్తారండి results? Anybody, can you guess?
Z cube minus cos x plus e power y plus xyz equals to
Scalar potential field. Okay. Pi is equal. చెప్పండి here.
Z cube minus cos x plus e power y
Z cube
minus cos x
minus cos x. Okay, good.
plus e power y
E power y plus
is xyz equals
xyz is equal to constant. Okay, so this is the direct problem. Okay, so if the problem is in this structure, no need to solve directly, just integrate first function of x, function of y, function of z, right to x plus y, x y plus xyz. Okay, that is the, I think, the previous class review. Okay, Nandi, so any doubts from the previous class? No more?